take a look at doing some operations with some radicals. We're going to take a look at doing some adding and subtracting, some multiplying, and then it's not quite dividing but dealing with division as we deal with it in radical world. First, we're going to take a look at adding and subtracting. Now, we can add and subtract what we call common radicals, and those are radicals that have the same number under the radical symbol. So before we can deal with adding and subtracting this lovely problem right here, what we're going to do is we're going to try and simplify. First, by taking the square root. I can see that this is a perfect square. The square root of 25 is 5. And then I'm going to leave the r to the fifth. We'll actually deal with the r to the fifth in just a moment when we're done doing our adding and subtracting. You could deal with it first, but I prefer to get the adding and subtracting out first. It makes the simplification just a little bit easier. Then we'll look at our next thing, and you'll notice that this is also a perfect square. The square root of 4 is 2. And again, we'll leave the r to the fifth underneath. And then we'll deal with our 100, also a perfect square. And the square root is 10, not 100. Sorry about that. So what I'm doing is I'm taking the square root of each number to get those numbers out in front. That tells me how many of these radicals I have. I have 5 of them minus 2 of them plus 10 of them. So I'm going to ignore the radical for now. I'm going to add and subtract them together, which we are allowed to do because they are all the same. These are the same values under the radical. They're exactly the same, which means they're like terms. So I could go ahead and add and subtract them. 5 of them minus 2 of them is 3 of them. 3 plus 10 is 13. Now the last thing I have to do is I have to simplify r to the fifth. Now if you remember, r to the fifth means 5 r's. And I could simplify that. Because we're doing a square root, I can take out multiples of 2. So I'm going to write r to the fifth like this. R to the fourth times r to the 1. The fourth is the biggest multiple of 2 less than 5. So it's the biggest even number less than 5, and the 1 is what's left over. Those together would be r to the fifth. I'm just breaking them down so I can do a little bit of simplification. When we take the square root of r to the fourth, remember what we do is we actually take that 4 and divide it in half. That's an r squared when it comes out of the radical. And what we're left with underneath is a single r. So that would be my solution in simplest terms. So you got to remember when you simplify those numbers, you want to take out even numbers because it's a square root or the index of the radical is 2. We want to take out multiples of 2, as many of them as we can, and then leave what's left over. The next thing we're going to look at doing is multiplying some radicals. And we're going to do this by multiplying a binomial times a binomial using FOIL. So we're going to start by multiplying the first times the first. I'm going to do each one in a different color. 2 times 3 is 6. And remember, square root of a times square root of a. Anytime we multiply a square root times a square root, that actually makes the root go away. So we have just a plain old a. And then we'll go ahead and we'll do our outer times our outer. Negative 2 times 2 is negative 4, and we do have that square root of a stuck to the term. Next, we're going to look at our inner times our inner. We'll do that in purple. 4 times 3 is a positive 12, and again we have that square root of a stuck in there. Last, we're going to go ahead and do the last times the last times last, kind of a tealish color. 4 times negative 2 is negative 8. Now we're almost done. We do have to combine these two middle terms. They are like terms. They both have the same thing under the radical exactly. So like above, we can combine them together and say negative 4 plus 12 is a positive 8 root a minus 8. And there you have your solution to the multiplication of radicals. The last thing we're going to talk about is dealing with division. Now, technically, we don't really do what we would call dividing a radical. What we're going to do is we're going to try and get this radical out of the bottom of the fraction. We don't like radicals in the bottom of the fraction because they are not what we consider to be in simplest terms. So I'm going to do what we call multiplying by the conjugate, and we'll see why we do this in just a moment. The conjugate is the same term as the bottom, so the square root r and the 6, only instead of the positive, we use a negative. So we always reverse the sign. If it's a positive, the conjugate has the negative. If it was a negative, the conjugate has the positive. You're allowed to do this as long as you multiply the top and the bottom by the same thing. So let's go ahead to see why we do this. So if we were to FOIL out the bottom, and we'll deal with the top in just a minute, first times first, root r times root r. We talked about when you multiply a root times a root, you're just left with what's underneath. So that's our r. We'll do outer times outer, negative 6 root r. We'll go ahead and do inner times inner. Positive 6 root r. And last but not least, last times last. Positive 6 times negative 6 is negative 36. Now look at what I have in the bottom. I have a negative 6 root r and a positive 6. Sorry about that r. Those cancel out, which is actually why I did this. So we're going to finish this problem out by multiplying the top, reminding that we multiply the 4 times both parts of the conjugate. So we have 4 root r minus 24. And I'm just going to write this a little bit more clearly so we see we don't have the crossed out on the bottom. We have the 4 root r minus 24 over r minus 36. So it's a lot of radicals to keep straight and a lot of rules to keep straight, but just keep in mind you're FOILing. Keep in mind if you're going to cancel or add or subtract terms, they have to have exactly the same thing under the radical. And always remember, a root times a root makes the root go away. That's what happens. A square root of r times a square root of r is going to do away with that root. So that's a look at some of your operations with radicals. Next, we'll talk about solving some equations and dealing with radicals that way.